Hello everyone. In this video, I'm going to talk about integer exponents. What's the meaning of an exponent? What are the formulas we need to know in order to solve an exponent exercise? So I'm going to list all the formulas and I will give an example on every single formula. In a later video, I will also solve some practice questions on integer exponents. All right. So first of all, if I have something like a and n at the top, where a and n are just numbers, this means what? This means I have to multiply a n times by itself. So a and n at the top means I have to multiply a n times by itself. We also have the following. The number at the bottom is called the base, and the number at the top is called the exponent. And how do we read it? We say a to the power of n, or simply a exponent n. So we either say a to the power of n, or we could say a exponent n. For example, if I have 3 to the power of 4, or 3 exponent 4, this means that I have to multiply 3 4 times by itself, which is 81. There is a common mistake here. Some students mistakenly write 3 to the power 4 as 3 times 4, and this is wrong. So please be careful not to fall into this trap. Now let us start listing the formulas that you need to know in order to solve an exponent exercise. So the first formula we have here is the following. If I have a to the power of m times a to the power of n, what do I mean by that? I mean if you have two numbers which have the same base, what about the exponent? We don't care. We might have the same exponents, we might have different exponents, we don't care. What we care about is that the two numbers should have the same base. If this happens, if this is the case, then I can say it is equal to a to the power of m plus n. In other words, if this is the case, I just add the exponents. For example, if I have 3 to the power of 4 times 3 to the power of 5, since I have the same base for both terms, I would say it's 3 to the power of 4 plus 5, which is simply 3 to the power of 9. So whenever I have multiplication, I add the exponents. Second, if I have two numbers, if I'm dividing two numbers with the same base, then this is equal to a to the power of m minus n. So dividing two numbers or two powers having the same base means that I have to subtract the exponents. For example, I might have 4 to the power of 7 divided by 4 to the power of, let's say, 6. This is equal to 4 to the power of 1. Another example would be 5 to the power of 2 divided by 5 to the power of 6. This becomes 5 to the power of negative 4. Why negative 4? Well, 2 minus 6 is negative 4. Third formula is the following. If I have a to the power of m, all of it to the power of n, so if you have two exponents on top of each other, I just multiply the corresponding exponents. So I multiply the exponents, this becomes a to the power of m times n. As a little example here, if I have 7 to the power of 4, all of it to the power of negative 6, this means what? 7 to the power of 4 times negative 6, which is of course 7 to the power of negative 24. Next formula. Any number to the power of 0 is always 1. So whatever the number to the power of 0 is always going to give me 1. And whatever the number to the power of 1, it is just itself. So for example here, if I have, let's say 12, it doesn't mean that it does not have any exponent if there is no number at the top. Well, I can simply add an exponent, which is 1. So any number to the power of 1 is just itself. Next formula. If you have a number with a negative exponent, and let us say you want to get rid of this minus, can I do that? Yes. That is equal simply to 1 over a to the power of n. So whenever you have a minus in the exponent, this means I have, in order to get rid of the minus, I can just move it from the top to the bottom or vice versa. To make it more clear, let me give you a couple of examples. Let's say you have very simply like 3 to the power of negative 2, and let's say this minus is just bothering me. I want to get rid of it. Okay, no problem. You can simply write it as 1 over 3 to the power of 2. Problem solved. Another example. You might have, let's say, a to the power of 4, b to the power of negative 2 over c to the power of, let's say, negative 5. Again, let's say I want to get rid of the minuses in the exponents. No problem. So a to the power of 4, I leave it. Now b to the negative 2, how do I convert it to b to the power of 2? Just move it to the bottom. So it becomes b to the power of 2. C to the negative 5, again, write it up. Move it up, so it becomes c to the power of 5. So whenever you want to get rid of the minus in the exponent, just change it from the top to the bottom or vice versa. Okay, so that's simply it. The next formula is ab to the power of n. If I have two numbers, I am multiplying these two numbers, and I have an n at the top. I have one exponent at the top, which acts on both numbers. I can simply say it's a to the power of n times b to the power of n. So if I am multiplying two numbers, and there are parentheses and there is an exponent outside these parentheses, I can simply distribute this exponent. Example, if I have, let's say, 2 times 5 to the power of 4, I can simply say it is 2 to the power of 4 times 5 to the power of 4, so I am just distributing the exponent. Next, similarly, if I have a quotient, like a fraction, a over b to the power of n, I can also distribute the exponents, a to the power of n over b to the power of n. As an example, very quickly, if I have 2 over, let's say, x to the power of 5, that is equal to 2 to the power of 5 over x to the power of 5. However, if I have a plus b to the power of n, if I am adding or, of course, subtracting, it is not equal. I cannot distribute the exponents. It's not equal to a to the power of n plus, or maybe minus, I don't know, depending on what you're doing, b to the power of n. This is not equal. I will do an example and show you the difference. Let's compare 3 plus 2 to the power of, let's say, 3, and 3 to the power of 3 plus 2 to the power of 3. Let's calculate each one individually and see if the answers match or not. So for the first expression, of course, I perform the operation inside the parentheses first. So 3 plus 2 is equal to 5 to the power of 3, and 5 to the power of 3 is 5 times 5 times 5, which is 125. On the other hand, I have to calculate this, 3 to the power of 3, which is 27, plus I do this, 2 to the power of 3 is 8, and 27 plus 8 is 35, and obviously they are not equal. So please be careful not to distribute the exponents if you have plus or minus in the middle. The next formula, well, there are two more formulas, very short formulas. Next, if you have minus to the power of an odd number, it's minus. So if I multiply minus odd times by itself, it is minus. And if I multiply it even times by itself, it'll be plus. So minus to the power of odd is minus, and minus to the power of even is plus. These are all the formulas you need to know in order to solve an exponent exercise. In the next video, I'm going to work out some exercises. Thank you.